Hi everybody, today we're going to be talking about what are the properties of a square. So take a look at this quick do now question and see if you can figure out what we're looking for. So for number one here, I'm looking for a property of a rectangle that a rhombus doesn't necessarily have. So you could have said one of a couple things. You could have said congruent diagonals, and you could have also said congruent angles or 4 right angles. For the rhombus, you could have said perpendicular diagonals or congruent sides, 4 congruent sides, or you could have said congruent consecutive sides, or diagonals bisect the vertex angles. Any of that would have been good. If you're wondering why this is how we're starting the lesson, hopefully you're starting to think about, well, what makes something a square? By definition, a square is a rectangle that has 2 congruent consecutive sides. Well, 2 congruent consecutive sides is what makes something a rhombus. So basically a square is a rectangle and a rhombus together. Keep in mind it's going to have all the properties of a rectangle, all the properties of rhombus, and also all the properties of a parallelogram, because rectangles and rhombi are also parallelograms. So squares have a ton of properties. Let's take a look at how we can use some of these properties to answer some questions. So number 1 and 2, you have 4 options. They're looking for the one that is not true. So pause the video and see if you can figure out which of the 4 choices for 1 is not true and which of the 4 choices for 2 is not true. So for number 1, let's look at our choices. Number 1 says AB congruent to BC. Well, AB and BC are congruent consecutive sides. That's a rhombus property, so that is true. AB and BD, AB is a side, BD is a diagonal. I'm not really sure. Let's leave that one for a minute. AB being perpendicular to BC, that would make angle B a right angle. We know that's true because that's a rectangle property, so that one's definitely true. And the last one, AB and CD being congruent. Well, that's a parallelogram property, so we know the correct answer of which one's not true is choice 3. Now the second one here, looking at the angles, angle 1 being congruent to angle 2, well, that would mean BD is bisecting the vertex angle. Again, that's a rhombus property, so that is true. 1 and 3, well, same thing, right? 3 and 4 are going to be congruent because the diagonal bisects it, but the whole angle B and the whole angle D are congruent because it's all right angles. So if the whole angle is congruent and they're both being bisected, all the pieces are going to be congruent. So 3 is true. 2 and 3 being congruent, let me erase this a little bit so you can see. 2 and 3 are actually alternate interior. And we do have alternate interior angles congruent because we have parallel sides. So that one is true. And finally, the correct answer is angle A being congruent to angle 4, which doesn't even make sense because A is a whole vertex angle and 4 is only part of a vertex angle. So definitely not true. Hopefully that wasn't too hard. Let's take a look at the next one here. Given that it's a square, let's find all these missing sides. Again, pause for a second. I think you'll be able to figure this out pretty quickly. So given AD is 20, I can find that AB is also 20. BC is also 20 because, again, all the sides are going to be congruent, and then DC is also 20. Now for the diagonals. Because it's a parallelogram, the diagonals bisect each other. So if that piece is 15, this piece is also 15. So the whole diagonal is going to be 30. And because it's a rectangle, diagonals are congruent. So that means these 2 pieces are also going to be 15 and the whole is also going to be 30. A lot of congruent stuff. Angle ABC, that's a whole corner. And because it's a rectangle, that's 90. Same thing with BCD. AEB is an angle in the middle. Well, in a rhombus, the diagonals are perpendicular. So you actually also have right angles here. Obviously, you have the vertical angle across from it as well. And then at the corners, again, the diagonal is bisecting them. So if the whole angle is 90, the piece is going to be 45. And that's actually going to be true for every single corner. So this one is also 45. Okay, not so bad. Let's take a look at how we actually do a proof involving a square. Now, the thing is the Regents doesn't often use squares. They're more likely to use rectangle and rhombi. So there isn't a ton of examples out there involving squares, but I have a couple for you nonetheless. And how that we're going to prove that something is a square is we can show it's a rectangle with congruent consecutive sides, basically a rectangle with a rhombus property, or we can show it's a rhombus with a right angle, which is a rhombus with a rectangle property. Basically, you have to show that it has a property of a rectangle and a property of a rhombus. Keep in mind, though, I still have to show, first and foremost, that it's a parallelogram because rectangle and rhombi are both parallelograms. So these proofs can kind of get kind of long. Fortunately for this one here, I actually know it's a square already. And they want me to prove something else. So that means I can use any property of a square in order to achieve my goal. And my goal for this proof is to prove that angle 1 and angle 2 are congruent. Take a minute. What is the relationship between angle 1 and 2? What might I have to use here? So hopefully you're realizing that angle 1 and 2 are alternate interior angles. If I have parallel lines, if NP is parallel to OM, then those angles are going to be congruent. So basically I have to show that NP and OM are parallel. So did I say congruent before? I meant parallel. Sorry about that. So how do I show that NP and OM are parallel? Hopefully you realize that it's a parallelogram property and squares are parallelograms. So I actually can already say it. So my second step here, NP is parallel to OM. Reason, in a square, opposite sides are parallel. Now I know that's a parallelogram property, and I guess you can say in a parallelogram, but you were given a square. So I feel like if you're going to say parallelogram, then you have to actually add a step saying a square is a parallelogram. To save yourself the time, just say in a square opposite sides are parallel, because that is also true. And then from here, I can say the angles are congruent or equal, because if two sides are parallel, then alternate interior angles are congruent. Done. Not so bad. Let's look at our next proof. Given SQUA is a rectangle and QU is congruent to UA, show that it's a square. So take a minute and see if you can figure out what kind of steps I'll have to include here. So they kind of did some of the work for us. They already told me it's a rectangle, which means I already know it's a parallelogram. I don't have to prove it's a rectangle. I don't have to prove it's a parallelogram. To show that it's a square, all I have to show is that one property of a rhombus is true here. And the given kind of set it up for us. QU is congruent to UA. That's the congruent consecutive sides. That already makes it a rhombus. So my next step is going to say SQUA is a rhombus. A rectangle with congruent consecutive sides is a rhombus. And then I can say it's a square. If a quadrilateral is a rectangle and a rhombus, then it's a square. Some people might just jump to step 3, because if you go back to our methods for proving that it's a square, it says a rectangle with 2 congruent consecutive sides. I like to add the step where you mention that it's a rhombus, because I like to have my students remember that squares are rectangle and rhombi. So that's just kind of a step that I like to put in, but technically you don't really need it. You can just jump right to saying it's a square. Okay, enough of that. Let's take a look at one more algebra question. See if you can find X, Y, and Z. I'm going to have you guys pause and see what you can figure out. So again, because it's a square, we know all 4 sides are congruent. So that's going to be our first step to finding X. So I'm actually going to set the consecutive sides congruent, because the opposite sides I'd have 2 variables and it wouldn't help me very much. So I'm going to set x squared equal to 2x squared minus 4. So I'm going to move x squared over to combine like terms. I get 0 equals x squared minus 4. I don't know if this is giving you some PTSD, but this is going to involve some factoring. Now, you actually can avoid factoring by moving the 4 over to the right and just taking the square root of both sides, but I think it's always a good opportunity to practice factoring. And this is an example of what we call dots, or difference of 2 perfect squares, where you factor the x squared to x and x, and the 4 to positive 2 and minus 2. That's how you factor a difference of 2 perfect squares. You make your little t-chart, set both sides equal to 0, and you get negative 2 and positive 2. Technically, those are both correct answers, because if I square the negative 2, I'm going to get a positive. So actually, both answers do work for x. Now, to get y, now I'm going to set the opposite sides equal to each other. So if I plug in 2, I get that y is 4. Not bad. And z, I actually don't have to do any calculation for, because we know the corners are all 90 and the diagonals bisect them. So half of 90 is 45 degrees, or 45. So that's the answer for next one. The last thing we need to talk about is how to do a coordinate proof. Now, just to warn you, these are quite a bit of work, especially for a square, because remember, you have to show it's a parallelogram, a rectangle, and a rhombus. And there's many, many, many different ways to do this and lots of different formulas that you can use. I'll go through one method, but keep in mind that there's a lot of ways to go about this. So let me plot it first. It's always good to have a visual. And double check that you plotted it correctly. That's the worst thing when you're trying to calculate stuff and one of your points is not plotted correctly. Okay, I want to prove that it's a square. The first thing that I'm going to do is show it's a parallelogram. And the way that I like to show something's a parallelogram is by doing the 4 slopes to show that you have opposite sides parallel. So I'm going to do the slope of MN, the slope of NA, the slope of EA, and the slope of ME. Okay. So counting boxes, you get 3 over 3, which is 1. You get negative 3 over 3, which is negative 1, 3 over 3, which is 1, and negative 3 over 3, which is negative 1. So again, I know that it's a square. My goal is to show it. So if you're not getting numbers that match up, like if you're not getting the same slopes, you know you're doing something wrong, because they're not saying, is it a square? They're telling you it is a square. So you kind of already know what you should be getting as your answers, right? You should be getting things that are the same. So now I need some conclusion sentences. So MN is parallel to EA because they have the same slope. NA is parallel to ME because they have the same slope. So mean is a parallelogram because opposite sides are parallel. So I'm done with the parallelogram part. And again, this is not the only way to do it. This is the way that I like to do it. Now I'm going to prove it's a rectangle. And the best part is I already have all the necessary calculation to prove it's a rectangle. Because what makes a rectangle different from a parallelogram is one right angle. A right angle means I need perpendicular lines at any one corner. I already have that, right? If you look at MN and NA, those are negative reciprocal slopes. So I already know I have perpendicular and I already know I have a right angle. I just need to say it. So MN is perpendicular to NA because the slopes are negative reciprocals. So angle N is a right angle because perpendicular lines form right angles. Mean is a rectangle because it's a parallelogram with one right angle. So technically it has 4, but all you have to do is show it has one right angle. Because if it has 1, based on opposite angles being congruent, it has all 4, and consecutive angles being congruent. So that takes care of the rectangle part and the parallelogram part. Now I have to show it's a rhombus. And again, I'm a personal fan of slope, so I'm going to continue with slope, and I'm going to find the slope of the diagonals and show that the diagonals are perpendicular, because that makes it a rhombus. That's not the only way. I could also do distance and show consecutive sides are congruent. Personally, I think slope is one of the easier formulas, so that's where I go to. So the slope of NE is 6 over 0. The slope of MA is 0 over 6. Now, at first glance, those don't look like negative reciprocals, but these are special slopes because one line is straight up and down vertically and one line is straight left and right horizontally. Those are special slopes. Like this one is undefined and this is a 0 slope. So those are negative reciprocals, which means they're perpendicular. NE is perpendicular to MA because the slopes are negative reciprocals. I apologize for my terrible handwriting in advance. That makes mean a rhombus because it is a parallelogram with perpendicular diagonals. Again, not the only way, just one way. And we are just about done. I need one more sentence stating that it is a square. Mean is a square because it's a rectangle and a rhombus. Or you can say it has the properties of a rectangle and a rhombus and a parallelogram, however you want to word it. So this is all the required work to prove that it's a square. Again, some methods might change. Instead of using slope, you might use distance. You can use midpoint formula, a lot of different things. But this is a lot of work, all of these coordinate proofs, particularly for squares. Hopefully you understood this, and thanks for watching.